Alright, in this video, alright, we're going to be sketching graphs of lines from equations that are given to us in standard form. Standard form of an equation is when you've got, it looks like this, ax plus by equals c, where a, b, and c are just numbers. Alright, so standard form, typically in standard form, your a, b, and your c are going to be integers. So the x and the y are on the same side. So the whole slope-intercept thing, where you can easily identify where's the y-intercept and what's the slope, doesn't work here. All right. So there are two different methods that I would use to do this type of problem. You could use whichever one you want, or you might learn to use both of them depending on the situation. One method is to take the equation and turn it into a slope-intercept equation. The other method is to use the equation as is to find the intercepts. Okay? Let's take a look. Alright, so on this particular one, I'm going to solve it for y to get that y equals mx plus b form. So what I'm going to do is, I got 2x minus y equals negative 3, and I'm just going to subtract 2y from both sides. And I'm going to end up with, my spacing is a little bit tough here, but it's going to end up as negative y, because remember the negative sign stays with the y, equals negative 3 minus 2x. Now, y equals mx plus b does not have a negative y, so we have to change it into a positive y, so times negative 1. So we end up with y equals, and I'm going to put the 2x over here, and it becomes positive, and this negative 3 also becomes positive. So y equals 2x plus 3. So now I know that the y-intercept is 3, and I can graph that pretty easily, and the slope is 2, or 2 over 1. So that's pretty easy to graph that as well. Okay. And there we are. Okay? All right. Okay, let's do the same thing over here. So I'm going to start out with 5x plus y equals 2. I'm going to subtract subtract 5x from both sides. And that's going to give me y equals a negative 5x and then a positive 2 over here. Now I'm in slope-intercept form. There's my intercept, my y-intercept. Our slope is negative 5, which means it goes, you can think of that as negative 5 over 1. 1, 2, 3, 4, 5, and over 1. And we can't plot any more points, but we can draw kind of the best line we can here. And there we go. Pretty straightforward. Take a look at another one. Okay. I'm going to do this one using the other method. We'll use this one using the other method here, okay? So, what I'm going to do here is, I'm going to find out what the y-intercept is by substituting a 0 for x. So, 6 times 0 plus y equals negative 3. That's y equals negative 3. And that's the y-intercept. We'll plot that. Negative 3. And now do the x-intercept. We just replace the y with a 0. So we have 6x plus 0 equals negative 3. 6x equals negative 3. We'll divide by 6 on both sides. X equals negative 3 over 6, which is negative 1/2. X equals negative 1/2. And that is our x-intercept. Okay? So our x-intercept is going to be right about there. Okay. Pause for 1 second. So you can see in your graph here that this goes down 3 and over 1/2. So down 3 and over 1/2. Going in reverse, up 3, back 1/2, up 3, back 1/2. And then we can draw our best line through there. Now, this one problem with this method is you notice our y-intercept, our x-intercept was a fraction. Half isn't too bad, but what if it had been like 1/3, or 5/8, or something even more difficult than that to deal with? It'd be troublesome to figure out what the over and up pattern was, what the slope was. So this example didn't work out too badly, but unless the trick you're looking for here is this number right here, that number here, the c, is it divisible by both a and b? So it was divisible by, the a here is a 1. So negative 3 is divisible by 1, but negative 3 is not divisible by 6. So when we divide them, we get that half. That's where we get that fraction from. And there's a case coming up. We'll see where it is by both numbers, and it'll be much better. All right, I'm going to do the rest of these. The next one is a solve for a y thing. Put it in slope-intercept form. All right, so here we've got 5x minus 4y equals 8. I'm going to subtract 5x from both sides. Negative 4y equals negative 5x plus 8. Then I'm going to divide by negative 4 on both sides. I get y equals, so negative 5 and over negative 4, they'll cancel each other out. And I'm going to get 5 over 4x plus 8 divided by negative 4. Oh, that would actually be minus 2. So our intercept is negative 2. And our slope is 5 over 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. Keep plotting more points. So let's draw our best line we can through. And there we go. Now, down here, got a couple of easy ones. Y equals negative 2. I think I've talked in previous videos about how to graph lines like this. If there's no x involved, then you just go to the y-axis. You plot that point. And then you just draw a line that cuts through the axis at that point. Y equals negative 2. Over here, x equals 4. Just go to 4 on the x-axis and draw a line that cuts through the axis at that point. Okay, pretty straightforward. Okay. All right, so here, do the same thing. I'm going to take here 2x plus y equals 0. And I'm going to subtract 2x from both sides, and I get y equals negative 2x, and I could say plus 0, but what's the point? So here, well, I'll put it in. All right, so my y-intercept is 0, as you see there. I have to write that down. And my slope is negative 2. We can think of that as negative 2 over 1. So that's down 2 over 1, down 2 over 1, down 2 over 1. Backing up, backing up, and backing up. Okay? And then there we go. Notice, this is a really interesting example of one where finding the intercepts would do you no good, right? Because look, you'd go 2 times 0 plus y equals 0, or y equals 0, the y-intercept is 0. Or you'd go 2x plus 0 equals 0, which means that x equals 0 as well. So you don't end up with two separate points, you just end up with one point, the origin. You can't graph a line with just one point. Okay, go next door. Here's an example of one that does work out pretty well using intercepts. So if I replace the x with a 0, and I get 0 minus y equals 4, I get y equals negative 4. There's my y-intercept. And if I go x minus 0 equals 4, I get x equals 4. I'll plot that. And you can see that this is one of those at a 45-degree angle lines. Be easy to graph. There you go. For most of these, however, I'd probably use the first method. Let's see, let's use this one here. So I've got 3x plus 2y equals 4. I'm going to take 3x from both sides. 2y equals negative 3x plus 4. Divide by 2. Y equals negative 3 halves x plus 2. So my y-intercept is 2. And my slope is negative 3/2, so down 3 over 2, down 3 over 2, back to up 3. Draw the best line I can through all those points. Okay. Oh. Sorry, picked my nose there. Okay, next one. Alright, here we got 5x plus 4y equals 0. I'm going to take 5x from both sides. 4y equals negative 5x. Y equals negative 5/4 x. So the y-intercept is 0. I could have written that in here, but I'm not going to. And the slope is 1, 2, 3, 4, 5. 1, 2, 3, 4. Going in the opposite direction, 1, 2, 3, 4, 5, 1, 2, 3, 4. And then, best line we can right through there. And there we go. Whew, man, I'm telling you. It is hot in here. It's like the hottest day of the year. Like trying not to burn up the AC. I'm running it all day. I got to kind of set it at a high temp. Ugh. Yeah, I don't know. I don't know if it's worth it. It's killing me. Okay. Here we go. Here's an example. I'm going to use the intercepts thing again. So I'm going to go 0 minus 2y equals 4. So that's negative 2y equals 4, or y equals negative 2. I'll plot that right here. And then I'll go x minus 2 times 0 equals 4, or x equals 4. And I'll plot that right here. And you can see that I got an over 2 up 1 pattern. Let's see how that works out pretty well. When, notice how the coefficient here was a 1, that's a 2, and 4 is divisible by both those numbers, so it worked out pretty well. This one here, this one would not work out so well. We'd end up with like 15 over 8. Terrible. So here we go. We've got 8x minus 5y equals negative 15. I'm going to take 8x away from both sides, so that gives me negative 8x minus 15. I'm going to divide by 5 on both sides. So y equals, now the two negatives here are going to cancel out. So I'm going to end up with 8/5 x plus, and 15 divided by 5 is 3. Well, negative 15 divided by negative 5 is 3. But, okay. So I plot 3. And our slope is 8/5, which means we go over 5 and up 8. We can't do that, so we're going to go in reverse. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And those are the only 2 points we can plot. Draw a line in. Okay, now, so as you can see, there are 2 methods for figuring out what the slope-intercept form is of one of these standard form equations. Remember, standard form is where you've got the coefficient and the x plus or minus coefficient, and the y equals some number. And the x and the y are both on the same side. Usually the coefficients are all integers. So then you can either turn it into a slope-intercept equation, like we did over here, by solving for y, which is typically, I'd say, the best method to use. Or you could find the intercepts and graph from that. To find the y-intercept, you just substitute 0 for x. And to find the x-intercept, you just substitute 0 for y. And if that seems like confusing and you just sort of forget, it's not that difficult, because you just substitute 0 for one of the variables, and then whatever you got left is going to be, you know, like y equals something, and then substitute for the other variable, and you'll get x equals something. And you just plot those numbers on the x and y axis. So, I mean, you don't have to remember which one to substitute. You just have to remember you need to substitute for both and just plot those 2 points. All right. Well, good luck for you on that one.